Alright, number 6 from the practice exam. So the question is, what is the major product of the following reaction sequence? So they give us this molecule. It's cyclopentane, 1-chloro, 1-methyl cyclopentane. And first, they treat it with ET. They treat it with so it's ETONA. So they're using is this called ethoxide? I don't know what this is called. Maybe it's called ethoxide. They're using this strong base in ethanol and heat. That's what they're doing to this molecule first. So then what they're doing is then after that they say they treat it with BH3 and THF, and then third they treat it with hydrogen peroxide, or just, I don't know if it's, maybe it's peroxide, H2O2, and NaOH, right? So this time I just incorporated this molecule into the background, so it's all done at the same time. So maybe it's a little bit quicker this time. So background, right? Okay, so this, I have right here this strong base in a product solvent being heated, and this molecule with an attached halide, electronegative halide, shows me this is gonna go through an E2 reaction mechanism, right? So that's the first thing that's gonna happen. There's gonna be an E2 reaction, I believe. So if we have our molecule here, right, here's a methyl group, here's chlorine, and there's 2 hydrogens here. So I'm treating it with, I think it's called ethoxide, but maybe if someone could look that up, that would be great. Ethoxide, so it's the ethoxide, and it's in ethanol. Yeah, so ETONA is called sodium, I think it's called sodium ethoxide. So when you put it in the solvent ethanol, it breaks up into the ethoxide ion and then the positive sodium cation, right? And then they're applying heat. So what's going to happen is that the base, the oxygen, the negative oxygen, is going to give 2 of its electrons to this hydrogen and pluck it off. Then that's going to give both of its bond electrons to this bond right here, creating a double bond. And then that's going to push off the chlorine, and the chlorine's going to escape. It's going to leave. It's a leaving group. And so we're going to be left with this molecule here. The methyl group stayed right where it was. A double bond formed where this hydrogen, hydrogen gave its electrons to this bond. And then since one of the hydrogens was taken by the ethoxide anion, there's only 1 H left now, right? Okay, so now we're going to deal with the second part with the BH3THF and then the peroxide and NaOH. So doing that, we got to look at the concept of alcohols from alkenes through hydroboration, oxidation, anti-Markovnikov synhydration. Alright, so we're using hydroboride. There's going to be a hydroboration, which is a mechanism, and oxidation, which is a mechanism. This entire mechanism is going to result in anti-Markovnikov addition, and it's going to be syn addition, meaning that the molecules are going to be added to both sides of, are going to be added to the same side of the double bond, and it's going to be hydration, right? And, okay. So, you always know that you're going to do this mechanism. The hydroboration, oxidation, anti-Markovnikov synhydration. When you see first BH3 and THF, and then peroxide with HO minus, so some variation of this. Now, okay, so this mechanism, when I did this mechanism, I just used the molecule that the question is on. Right, and step 1 is hydroboration. So here's the molecule that we made previously. Right, it's CH3 and CH3. Now remember this bond right here. So these are trigonoplanar. They're flat. They're only bonded to, it's a carbon bonded to 3 other groups, and so it's trigonoplanar. So what happens is this BH3 molecule, which is suspended in THF, can it's going to be anti-Markovnikov syn addition, which basically, so because these are flat, because they're trigonoplanar, this can attack from the top, or it can go underneath and attack from the bottom. So that's why what's going to happen is you're going to get 2 enantiomers, right? So the first one, if it attacks, first let's deal with the anti-Markovnikov part. This has an H, right? And so this is going to give an H and a BH2 to this group. You would think that the H is going to go here, but this is anti-Markovnikov, so the H goes to CH3. So what happens was, we're going to, okay, the first enantiomer we're going to do, it's syn addition. There are the BH and the BH2 and the BH are going to come from the same side of that double bond, and they're going to come from underneath. So coming from underneath, here's the H, this is this H, and the CH3. And then where the H was, when usually you would think another H would go there, the BH2 is going to go there. The BH, the bromine complex. And the H is going to go where it usually wouldn't, where there was no H before. And then there's going to be the enantiomer, right? Because this complex can go under or it can go on top. So the enantiomer that will form will be like this. So let's say it comes from the top. This H gets pushed down. The CH3 over here gets pushed down. And then we have the BH2 on top and the H on top. So these are the enantiomers, you know, either coming from the bottom where they're both underneath or coming from the top where they're both on top. So then we got to do step 2. And this is a whole long mechanism, but this is just the truncated form. So we have step 2 when we treat this with peroxide and the hydroxyl group, and it says the boron is replaced with OH, and there is retention of configuration, meaning there's no changes in the configuration of the molecule. So wherever you saw the BH, it gets replaced with an OH. That's the only thing that really changes here. Right? So that's where the BH was in this molecule, right? And now so it's just getting replaced with an OH. And then everything else stays the same. And then let's also look at the enantiomer. If we subject this enantiomer to oxidation with hydroxide and an OH, wherever the BH2 was gets replaced with OH, and that's the only thing that changes. There's no change in configuration. Up OH, H, CH3, and H, and these two, of course, are enantiomers. So on the test, it asks what, when you're looking for the answer, there's two that give enantiomers, right? One shows the OH group and the methyl group being on the same, both projecting out, and one gives them cis. One gives the answers that the methyl group, and the hydroxyl group are cis, meaning they're both coming out of the page, and one gives it that they're trans, meaning one's coming out and one's going in the page, and they're what's it called? Right, plus the enantiomer. So when we look at this, we can see that they have to be trans. The OH is going into the page, the CH3 is coming out. The OH is going out of the page, it's coming out of the page, the CH3 is going in. So they're opposite, so that's why the answer on the test is C.